Here's a law of nature they don't tell you. The better your app does, the harder it tries to die. 10 users? Your server purrs. 100,000 users, all at once? It chokes, it slows, and then it just falls over. Success becomes the cause of death. Last time we walked the front end, the bright, sunny surface the user actually touches. Today we cross the ridge and climb down. Beneath the screen. Into the wiring nobody sees but everything depends on. This is the backend. And there's exactly one story we're chasing down here, how a dumb server, a glorified warehouse shelf, slowly woke up and learned to think. No memorizing. We follow the pressure, what problem pushed up each tool, and the names just stick. Rewind to the early 90s. Back then a server was almost insultingly simple. You ask for an address, it grabs the matching HTML file off a shelf and hands it over. Untouched. Like a librarian fetching a book by its call number, it doesn't read the book, doesn't edit it, just fetches it. Same page for everyone, every time. We call that a static page. Then, around 1993, the first wall. People wanted a guestbook. A visitor counter. A search box. If I leave a note, it should show up. And here's the trap, who's going to visit, when, and what they'll write. You can't know any of it in advance. And if you can't know it, you can't build the page in advance. So the whole idea flips inside out. If you can't build it ahead of time, then build it right there, the instant the request lands. Not a finished burger pulled off a warming rack, but one assembled the moment your order comes in. That's a dynamic page. And that humble little guestbook? That was the first jolt of electricity that dragged the server out of the warehouse and made it think. This is the doorway to the entire backend. The server stops being a shelf fetcher and becomes a manufacturer. Build the HTML on the spot. Easy to say. But how? The first tool, out in November 1993, was CGI, a bridge that lets the server run an external program and ship back whatever it produces. The man who first built it was Rob McCool, working on a web server at a lab called NCSA. Why gateway in the name? Because the web was a newborn, and companies already had databases humming everywhere. The server needed one common gateway through to all of them. McCool built the floor that every dynamic web would later stand on, the supporting actor who built the whole stage. Then, in 1994, PHP shows up and explodes on one clever move. It lets you tuck server code right inside your HTML. Barrier to entry, gone. For years a huge slice of the web ran on it. Wikipedia. Early Facebook. And the creator? Rasmus Lerdorf. Listen to what he actually said: I really hate programming. I built this tool to do less programming. The language was born out of pure laziness. I hate writing the same thing twice. Which, honestly, is the entire spirit of good code. Laziness, now and then, is the mother of invention. The tool names kept changing: PHP, Python, Java, Node, Go, but the core idea is one line: the server manufactures the screen at request time and hands it back. The fancy term is server-side rendering. Just red rendering is building the screen. Who builds it? The server. Hence, server-side. And please, don't panic because names are raining down on you. They're all different tools doing the exact same job. Memorizing the tool catalog isn't backend. Gripping one tool properly is. So what's inside these tools? Here's where people freeze up. Wait, I have to learn to program? Relax. Whether it's PHP or Python or Go, crack it open and it's built from the same 5 parts. Variable, a labeled bowl that holds a value. Conditional, a signpost at a fork: if logged in, greet them; if not, show the login. Loop, do the same job 100 times without writing it 100 times. Function, tie 12 steps to a single button you press by name. And type, is this 10 a number you can add, or text you can't? Learn these 5 in one language, and every other language is just a different accent. You're learning 5 things. Not 5 languages. Now, the guestbook grows up. Search gets bolted on, then sign up, then comments, and suddenly the code that draws the screen, pulls the data, and controls the flow are all tangled in one file. A swamp. Fix one line and something unrelated explodes. That's not a code problem. It's a tidiness problem. When a house grows, you split it into rooms. The method that came out is MVC. Model, the home of the data. View, the interior decorator who draws the screen. Controller, the on-site foreman directing traffic. 3 wires, tied off separately by color, so whoever shows up later can tell which is which. So where do the real rules of your service live? Free shipping over $50. Can't post the same note twice in a minute. That's business logic, and you keep it in one place, in the model, never scattered across the screen. The second it seeps into the view, the swamp starts again. And here's the whole chapter in one line. Strip away every flashy feature in the backend is just a data system. Take a request, fetch or save data, return a result. Whatever you meet from here, ask one thing: what data is this pulling, from where, and how is it handing it back, and you'll always see the path. Now, 2007. Something detonates. The iPhone. Until then, a web service had one guest, the browser. And to the browser, the server printed one finished sheet of HTML. Done. Then apps arrived, and suddenly some people view your service through a browser, others through an app. But an app carries its own buttons, its own screen parts. It doesn't want your finished picture. It wants the filling, the raw data. This person's name is Kim, they have 3 posts. So the server changes its whole line of business, from a print shop making finished pages to a wholesaler selling nothing but data. The wholesaler needs a counter where guests pick up materials. That counter is the API. The app knocks in a fixed way, give me the user list, and the server hands data back in a fixed way. Each counter gets an address, an endpoint, users at /users, posts at /posts. And what flows across the counter? A format both sides can read, called JSON. Keys and values, plain text. Name, Kim. Age, 32. Admin? No. A human gets the gist, a machine reads it precisely. Fun fact, nobody invented JSON. Douglas Crockford says he discovered it, sitting there inside JavaScript, named it, and described why it was useful. Good formats are found, not forced. Then there's REST, where almost everyone trips. REST is not a program or a tool. It's an agreement, a style, for designing your counters consistently. Treat everything as a resource, a user, a post, and change what you do to it by swapping the action. Read with get, create with post, update with put, delete with delete. Same address, different verb. And the backstory kills me. REST came from Roy Fielding, a grad student in the 90s chasing one question nobody bothered to ask: why does the web work as well as it does? It was a 6-year PhD thesis about the web itself long before anyone said the word API. Knock on a counter, and the server answers with a 3-digit status code. Do not memorize them. Just read the first digit. 200s mean success. 300s, go somewhere else. 400s, that one's your fault, the sender's fault, the famous 404, there's nothing at that address. And 500s, that's the server's fault, it fell over building the answer. Here's a bitter little irony. Fielding once watched people slap REST API on things that weren't REST at all, and snapped in public, "This is RPC." It screams RPC. He built the concept, and then had to watch it get used for the opposite of what he meant. The fate of a creator. Now for a slightly absurd fact. The server has no memory. HTTP is stateless, every request is treated like a stranger it's never seen. Picture a front desk clerk who's brilliant but forgets you in 0 seconds. I'd like to log in. Handled perfectly. You step back, step forward, show me my info. And the clerk says, "Who are you?" That breaks login entirely. So we invented a device to bolt memory onto this goldfish clerk, the session and the cookie. The clerk scribbles a note in a drawer: "Customer 37 is Kim, logged in," and tears you off a numbered ticket that says 37. But who carries that ticket between visits? The cookie. It's a little pouch on the browser side that tucks the ticket away and auto-attaches it to every future request. You never shout, "I'm 37" again, the browser presents it for you. And the cookie's origin? Not ad tracking, that came later. In 1994, Lou Montulli at Netscape was building an online shopping cart, and needed to remember a user without storing state on the server. The name came from Magic Cookie, a phrase he'd heard in a college operating systems class. One of the most spoken words on the internet came from a single lecture. 2 words everyone blurs together: authentication and authorization. Authentication asks, "Who are you?" proving you're really Kim at the door. Authorization asks, "Are you allowed to do this? You got in the building?" "Sure, but a regular employee stops at the office, only an admin reaches the server room." Authentication first, authorization second. Miss that second check and you build the classic hole, anyone logged in can delete anyone else's post. The thing beginners skip most is exactly this, permission. The session works, but it has a weak spot. Grow big, and one clerk becomes many servers. But the drawer with your notes sits on clerk number 1's desk. Go to clerk number 2, and who are you, all over again. So the idea flips, JWT. Instead of leaving a note in the drawer, write everything onto the ticket itself and hand it to the customer whole. Any clerk can just check the ticket. Now, a JWT is not encrypted. Its contents are a letter anyone can unfold and read, with a wax seal stamped on it. The seal stops forgery, not reading. So never, ever write a password into it. It's all visible. Speaking of passwords, the server should never know yours. If it stored passwords as is, one database breach leaks every single one. So passwords go through hashing. Think of a grinder, feed an apple, you always get the same jam, but from the jam, you can never get back to the apple. The server stores the jam. At login, it grinds what you typed and compares jam to jam. So even the server doesn't know your real password. That's why, when you forget it, it can't tell you what it was, it makes you reset it. Hashing is a one-way street. Encryption is a lock you can reopen. Passwords take the one-way street. Let's compress everything the backend does with data into 4 actions. Create, read, update, delete. First letters, CRUD. Post a photo, that's create. Scroll the feed, read. Fix the caption, update. Take it down, delete. Pick any app you use. Tear its flashiest feature apart and it's just these 4, laced together. And they snap right onto rest, create is post, read is get, update is put, delete is delete. Same counter, swap the verb. CRUD and REST are the front and back of one picture. Honestly, a huge part of backend work is just laying out these 4, neatly, for each resource. Okay, the server runs. Now the real job, keeping it alive. And the number 1 reason it slows down? It handles one thing at a time. Picture a one-person snack bar. A customer orders a rice roll, 5 minutes to make, and the owner just stands there while it cooks, as 100 people who want a 30-second snack stamp their feet in line. Absurd. But that's a naive server. Here's the key, the problem isn't making the roll. It's that the owner does nothing while waiting. So, asynchronous. Lay the rice down, and while it cooks, take the next order. Don't let the waiting time idle. That's the whole idea. One word that tags along here trips everyone, concurrency. It does not mean doing many things at the exact same instant. One owner physically cannot roll rice and fry snacks simultaneously, they flit rapidly between the two so it feels simultaneous. Actually doing things at the same instant, with many hands, is a separate word, parallelism. Lock it in, concurrency is one worker finally alternating so it looks simultaneous. Parallelism is many workers truly at once. Concurrency is the composition of work, parallelism is the execution of it. Even spending the waiting time wisely, one slow stretch remains, the database. A DB keeps its data on disk, and pulling from disk is sluggish as a snail. And here's the maddening part, thousands of people per second ask for the same data. A hot post's view count, the front page product list. Every time, the server crawls down to the slow disk and hauls up the same answer. Drawing the same well water, thousands of times a second. So, the cache. Pull the popular stuff out into a fast spot ahead of time and serve it from there. Like putting gum by the register instead of in the warehouse. You're giving the database reflexes. The star of caching is Redis, and it keeps its data in memory, not on disk, so it comes back in a blink. And the guy who built it? Salvatore Sanfilippo, a solo developer from Sicily. His origin story is perfect. Back in the 90s he tried to buy a graphics card and bought a modem by mistake, and that accident pulled him onto the internet. He built Redis to keep his own little analytics service alive, a service that later handled 2 billion page views on a single $150 a month machine. When he posted Redis online, it got 5 comments, 3 of them a shrug. That shabby little debut is now the reflexes of half the web. One trap with caching, one word, TTL, a cache's shelf life. If the original data changes but the cache still holds the old value, you serve stale info. So you stamp an expiry, good for 5 minutes. Too long, you serve spoiled data, too short, the cache barely helps. That tightrope is the heart of cache design. And caches aren't just for data. Scatter copies of your images and videos across the globe so a user grabs them from the nearest spot. That's a CDN. Same idea as caching. Instead of the far, slow original, pull from a near, fast copy. Now set speed aside for something scarier, data going wrong. A fast server that gives wrong answers is 100 times more dangerous than a slow one, especially with money. A transfer. A sends B $10. The server subtracts 10 from A, then adds 10 to B. But what if it dies from a power cut right between the two steps? $10 left A and never reached B, evaporated. So we built the transaction, bundle both steps into one unit where either all of it happens, or none of it does. Accident midway? Roll it all back, as if it never happened. Both succeed? Commit, confirmed, no takebacks. A transaction keeps 4 promises, and we take the initials, ACID. Atomicity, all or nothing, the one that blocks the evaporating $10. Consistency, no defined rule gets broken, like a balance never going negative. Isolation, even with many deals at once, they don't tangle. Durability, once committed, it survives even a power cut. Read each letter as which accident does it block, and there's nothing to memorize. Fun fact, the concept came from database legend Jim Gray, but the catchy word ACID was coined 2 years later by 2 other researchers. The bundle we memorize is a 2-generation collaboration. Users keep climbing. One day, one server can't take it. Fork in the path. Path 1, scale up, swap your server for a beefier one. A 1-ton truck becomes a 5-ton truck. Simple, but the truck doesn't grow forever, the price goes unreal, and if that one machine dies, everything dies with it. Path 2, scale out, don't grow one machine, run many copies. 10 1-ton trucks instead of 1. In theory, no limit, one breaks, the other 9 roll on. YouTube, Instagram, all this path. Don't grow. Add. That one line is a turning point in backend thinking. But 10 trucks raise a question, who decides which truck gets the next load? Pilot all on one and it overworks while the rest sit idle. So you station a traffic cop at the door, the load balancer, spreading requests evenly so no single server collapses. Bonus, if one server quietly dies, the load balancer notices and just stops sending it work. The user never even knows. That's why scaling out buys you stability, not just power. And don't overreach. For a small service, one good server is cheaper and simpler. Scale out when one machine genuinely won't do, not on day one. So far we've talked as if it's one giant building, login, products, orders, payment, all crammed in one place. That's a monolith. Comfy at first. But the payment feature catches fire, and the login renting a room upstairs burns down with it. One local accident becomes total. So, microservices. Chop the boulder by function, each in its own building. Payment burns, login is fine. Fix only reviews? Rebuild only the review shop. And how do the buildings hand work to each other? A message queue and order slip spike. Pin the slip, walk away, the kitchen works the slips at its own pace. Even if one service is dozing, the jobs wait in the queue. Nothing gets lost. Last ridge. Everything so far was request response, the client asks, the server answers, done. The server never speaks first. But some features can't live like that. Chat. Live alerts. Stock tickers. They all need the server to speak first. A message arrived, before you even ask. Fake it with request response and the client has to nag, once a second, anything new? Anything new? 99 no's out of 100. That's polling, and it's a waste. So, WebSocket, keep the call connected, both sides talk freely, like a phone call. Perfect for chat. Or, lighter, SSE, a one-way radio broadcast, server to client, for alerts and feeds. Don't reach for WebSocket by default. Ask first, do I actually need two-way? Alright. Look at the ridge we just climbed. The server went from a dumb warehouse shelf to a manufacturer, static to dynamic, CGI to PHP, 5 parts, and MVC. Then it stopped shipping finished screens and started selling data, the API, JSON, REST, and the sessions, cookies, and tokens that let a memoryless clerk remember you. And then it learned to stay up without falling over. Async spent the waiting time. Caching gave the database reflexes. Transactions kept the money from evaporating. Scaling added trucks instead of growing one. Microservices split the risk. And real-time let the server finally speak first. Notice, not one of these was a term to memorize. Every single one was an answer born from a problem. Traffic piled up, so async appeared. The DB was slow, so caching appeared. Money vanished, so transactions appeared. Hold on to why was it born, and you can read any backend you ever meet. Everything you just learned is region 2 of a book called the AI Development Atlas. 10 regions, 1 map, the front end you can see, the back end you can't, and 8 more ridges beyond. It's written so you can command the machine instead of riding shotgun while it drives. If the underground wiring makes a little more sense now, the book is the whole map. Its tagline says it best, only those who know the terrain can command the AI. This has been a DK Corp production. We build the maps so you can command the machines.